Hello friends, welcome to yet another video in a series of videos where we discuss about previous year's NEET JEE question papers. If you have not watched my previous videos, please do watch it. The links are in the description below and the I button, and find all the videos over there. My name is Naveen Kumar and you're watching my YouTube channel. So for today, we will discuss about a question which is taken from previous year JEE question paper, and it is connected to one of the chapter in +1, which is gravitation. So without wasting any time, let's get started. So let's look at the question. Four identical particles of mass m are located at the corners of a square with the side length a. Let's look at the figure. There are four masses here, 1, 2, 3 and 4. Let's mark this particular points as, let's call it as P, Q, R and S to understand the question. What should be the speeds if each of them revolves under the influence of other's gravitational field in a circular orbit circumscribing the square? That means these four masses are rotating around some center which is shown at the particular point right over there. That means it is concentrated with all the four masses rotating around an imaginary point, and that imaginary point is the center of that circle. Let's mark the distances as A. Here also I could mark it as A. Here also it is A and A. So here we have to find out what should be the speed if each of them revolves under the influence of others' gravitational field in a circular orbit that is circumscribing the square. Okay. So what we need to find out here is the speed of rotation of all the four masses, and here we have said that all the four masses are of equal magnitude. So we will be able to understand that these four masses are rotating around the circle with some imaginary center because of the only presence of gravitational force between these four masses. And since all the four masses are same, we can say that one mass is rotating around the circle due to the contribution of the force created by the other three masses. So we just have to concentrate on one of the mass and calculate the total force acting on the mass and then equate it with the centripetal force acting on that mass. That is what we have to do it. So we'll start with here and start marking the direction of gravitational force, and we have to understand that gravitational force is an attractive force. So if gravitational force, if I mark it as so that the gravitational force acting on the point P due to the point Q can be shown by an arrow like this, because it's a gravitational force, so that it's an attractive force, so that it gets attracted towards the other mass. Let's concentrate it and let's put it as F point Q. So we can say that it is the gravitational force created by the mass m which is at the point Q on the point P. Okay. Similarly, we can mark it here. Another mass is there which is the point S. So I can mark it as Fs. Similarly, there is another point on the point Q. That mass also tends to attract this particular point P towards itself, so that we can say that this is another direction of the force which I can mark it as F due to the mass at the point R. So individually calculate what is the total force acting at the point P due to the other three masses. So let's start with the calculating the magnitude of FQ. That means let's mark it as FQ, which is equal to, we are applying Newton's universal law of gravitation. We have studied. So it is G, two masses. What are the products of the two masses? m into m, we call it m square, which are the two m's, the mass which is at the point P and mass which is at the point Q, divided by the distance between them. What's the distance between them? It's called a square. Similarly, I can find out the magnitude of the mass which is at S. Let's call it Fs, is equal to, similarly I can write it G into m square divided by a square. Why? Because this is also at the same distance A. Okay, now let's calculate what is the resultant of these two forces. That means these two forces are acting on the point P by the masses at Q and S, and they make an angle of 90 degree between each other. So what will be the resultant force? How will you calculate the resultant force? For that we have to use parallelogram law of vector addition. If you want more videos on parallelogram law of vector addition, put a comment below in the comment section. I'll try making a video for you. Right. So if I write it as FQS, what is that FQS? It is the magnitude of the resultant force which is created by the combination of FQ and Fs, which can be written equal to square root of magnitude of the first force, that is Fq square, plus the second force, that is Fs square, plus these are all under the root 2 times Fq Fs, and this is multiplied by the angle between the two forces. The angle between the two forces is 90 degree, that is the angle between, or the cos of the angle between the two forces, which is 90 degree, which you can write this is equal to cos of 90 degree as 0, as you know it. So that what is going to happen is, if you look at the magnitude of Fq and Fs, they are both same, so that I can say that it can be written equal to, if you substitute it, you will get root 2 times the magnitude of one of the force. What is the magnitude of one of the force? You can take the square root, so that you will get gm square by a square. I think you probably have understood that. If you just have to substitute this both are having the same magnitude, what will happen? They get added together, giving you a 2 inside the bracket. Since both are having the same magnitude, we can take common out. What is the common out? Gm square divided by a square, the whole square, with a square root, which will give you the value as gm square divided by a square. You can work it out on your own and find out. Now we are going to calculate the force created by the mass at the point R, so that we can calculate it as is equal to. Now before we calculate that, we also have to show you the direction of the resultant force of FQS, which is that this is the force in which it is going to act, which is going to be shown with the letter FQS. That is this direction, that is this direction, that is the direction parallel to the diagonal. Okay, now if I can write down the force created by probably the force created by R, that is also along the diagonal, that is also gm square divided by the distance between the two masses. If this is a, if I use Pythagoras theorem, we can say that it is equal to root 2 times a, so that I can say that it's equal to root 2 times a the whole square. That means that distance from P to R is a root 2 times a, that the square of that value, which will give you is equal to gm square divided by 2a square. This is the value of f of R. That means I can say, drawing it towards this direction, as this is the direction of FR, that is the same direction as FQS, with the same direction, both are in the same direction, so that the resultant direction of the force acting on the point P, that means I can say that this is the force acting on the point P, that's the total force acting on the point P, will be, since the resultant of FR and FQS are both in the same direction, we can add these two together. What are the two forces? We'll start writing it as, what are the two forces, which is R, force contributed by R, plus the force contributed by QS, which can be written equal to gm square divided by 2a square plus root 2 times gm square divided by a square equal to, we can say that it's equal to gm square divided by a square times root 2, root 2 is a common out here, plus half, which I can probably write it as gm square divided by a square times 2 root 2 plus 1 divided by 2, which is the resultant force acting on the mass kept at the point P. So now this total force acting on the point P we have found out, and we can say that this force is responsible for this mass to go around the circle. Similarly, the same magnitude of force is going to act on the point Q, similarly on the point R and at the point S. And since they are equal distance apart and having the same magnitude, we can say that all the four masses will have the same velocity. And if I want to find out the resultant velocity, or if I want to find out the velocity of one of the masses, all the four masses have got the same velocity. If I want to find out the velocity of one of the mass, I have to equate this gravitational force which is acting on the point P with the centripetal force which is also acting towards the center. In short, if I say this gravitational force acting on the point P is responsible for the centripetal force acting towards the center, so that I can write it as the force which is acting on the point mass at the point P is equal to the centripetal force. We can write it as gm square divided by a square times 2 root 2 plus 1 divided by 2, which becomes equal to the centripetal force acting on the mass m. What is the centripetal force? Look at the figure. The centripetal force will be mv square divided by r. What is r? R is the radius of rotation. Now look at this particular figure. We can say that this total distance is root 2a. We have already calculated that. That means a radius here will be equal to half of this particular total length from P to R. What is the half length of that? Root 2a divided by 2. We can say that it is equal to a by root 2. So if I substitute that here, we can say that it's equal to mv square divided by, what is the distance? A by root 2. Now here what we just have to do is we just have to manipulate these equations, cancelling the same terms over here. We could write it as gm square, gm, m and n could cancel out here. One of the m could cancel out, giving you v square is equal to gm divided by a times 2 root 2 plus 1 divided by 2 root 2 equal to, can separate out the values, you will get as 1 plus 1 divided by 2 root 2. 1 by root 2 is 0.707. To gm divided by a times 1 plus 1 divided by 2 root 2, and you will get this value equal to gm divided by a times 1.35. okay, now this is v square. What is v? Will be equal to square root of gm divided by a times square root of 1.35, which is equal to square root of gm divided by a times 1.16. We could write it as 1.16 times root 2 gm divided by a is the equation or value of velocity. If you look at the four options, this is the right option. So here, to summarize this, what we have done here is to calculate the velocity. What we have done, we have taken three most important equations, starting with Newton's universal law of gravitation, second is parallelogram law of vectors, and the third is centripetal force. We have equated the gravitational force with the centripetal force. I believe you understood.
So if you like my video, please hit that like button and share with all your friends. Don't forget to hit that bell icon so that you get all my notifications whenever I upload a new video for you. Until next time, be happy and enjoy your studies.